Hello my friends, this is 13th issue of the Weekly Links. I really want to know how do you find my show, and if you like it, please give me a thumbs up and write a comment. What's in the agenda today? A little about Google Guava, again, 2 articles about GPE, and a great article from Open Liberty on how to reduce startup time of the cloud-native applications written in Java. My name is Alexander Barmin, and this is my channel. Brew your morning coffee, set up a timer, subscribe to my channel, and let's get started. Our application ordinarily consists of at least 2 parts, server part and client part. Yes, obviously, we may have more services or layers in the middle, some caching, distributed content delivery networks, and so on. But in common, ordinarily we have at least 2 parts, server and client. As a client, we may have web application, for example, or mobile application, or any other kind of the client that communicates with the backend via some API. And here we have finally reached a question, how client should know where is the server. Here we have multiple options. As ordinary, the easiest option is to hardcode it somewhere. For example, we have a front-end application written in React, and this front-end application is built using a collection of environment variables for different environments. This collection of environment variables stored in file is for dev, another for pre, another for staging, and for production. This is the easiest approach, and as ordinary it has drawbacks. First of all, we need to rebuild the application for different environments, and secondly, when backend moves to a new URL, it is necessary to release a new version of the front-end application as well. So server and client parts might not be in sync for some time. You may say that it is actually not happening regularly, but in case if the backend is generated automatically using, for example, AWS AppSync, this might be an issue. Okay, there should be a way to keep them in sync, and the next option is to use relative URLs. For example, our client application, like web application, is delivered from domain like example.com, and the backend is available at example.com/API. Looks easy, but again, this approach doesn't work for mobile applications. They do not have base URLs at all. Well, we also may have a third option, like a combination of the first and second. What if we have a static URL that returns information about other resources required for the application to work? You may say that you have never heard about this approach, but actually we have OAuth that works in exact same way. We have .known hosts endpoint that return information about other endpoints. So roughly speaking, we can use the same approach in our own applications. What approach do you use in your app? Please describe it in the comments. Moving forward, the second article from my list is another post from Bildung website, and this time it is about using Google Guava library for dealing with files. Well, you may argue, we already have Neo and it is very convenient, but still there are some scenarios where Guava.io can help us. So let's start with the simplest scenario. Guava offers a utility class files for reading and writing, and in case if we want to write to a file, we may use files.write. Here we can pass content and charset as parameters. If we need to write multiple lines, we can use charsync and write collection to files using it. We can deal not only with strings but also with bytes, and here bytesync can help us. Reading with Guava.io is also simple. We do not need to care about resources and can read files as a collection of string, as one single string, or as a byte or string source. Another important thing to be aware of is resources class, because it allows us to read from resources located in class path, for example, from some files from your jar. Let's talk about GPE, because we've been talking about it a few issues in a row already. Every Java object has a few methods inherited from the object class. 2 of them are equals and hashcode. Equals and hashcode should follow a contract. For example, equals should be reflexive, symmetric, transitive, consistent, and for null references it should always return false. For hashcode we also have rules. It should be consistent, and if objects are equals, they should have the same hashcode, but in case objects have the same hashcode, they may not be equal. This is contract. JPA entities are not very regular classes, and there are some special rules for their equals and hash code. And the rule of thumb here is that if your entity has a primary key and some business or natural keys, these exact values should be used for equals and hash code implementation. Ordinary and regularly during implementation of equals and hash code, we need to check if both objects are of the same class. And to do that, getClass method is ordinarily used, and this approach works for majority of scenarios. JPA Common and Hibernate in particular are very eager to use proxies so standard implementations that use getClass method may not work as expected. In this scenario, getClass will return name of the proxy rather than class of the entity. Luckily, we have Hibernate.getClass method, which allows us to gracefully dereference Hibernate proxies, so I strongly recommend you to read an article and learn more about caveats and implementation of equals and hash code for JPA entities, especially in cases if we deal with proxies a lot. Another JPA related article in my list is about soft deletes. Idea of the soft delete is that when you need to delete the record from the database, it is not physically deleted from a table. Instead, the record obtains a flag saying that it should not be retrieved or appear in the search results. The main complexity dealing with soft deleted records is that now they have this flag, and executing every single query we should keep it in mind. Or shouldn't? Actually, no. We shouldn't, because JPA offers a collection of annotations that allow us to overwrite a query that is executed when the record should be deleted. In our scenario, the deleted flag should be set to true, or when a record is retrieved from database by key or by query. All these three annotations allow us to configure JPA to support soft deletes. And by the way, do you use soft deletes or directly remove records from the database? Write it in comments. Last but not least, we all know that Java is slow, super slow, extremely slow. It is slow when it starts, but next it has outstanding performance without no doubts. Okay, what I say that it is possible to avoid cold start of the application and restore the snapshot of the warmed up application that is ready to work with peak performance. Engineers from IBM decided to use Linux checkpoint and restore in user space feature to take a snapshot of a running Java application, and when it is actually needed to start the application, it is restored from the snapshot in milliseconds instead of doing a cold start. This approach works in containers and requires IBM Semero JDK at the moment, but actually makes Java applicable for use cases when the application should have instant start, like in serverless scenarios. The article explains how to build a Docker image that will utilize this feature, so read an article. That's it for today, hope you enjoyed the video. If so, please give me a like, subscribe to my channel, and see you next week. Bye!